on the one hand, we have TUV from testing, long G wafers and modules, ICO active in cells. Then we have Hangzhou first in encapsulation, Solis Jinlong in inverters, and we will have also, and that's very great to have someone from the demand side, that is RES, who's one of the leading global renewables developers. After the presentations, we, from these various stakeholders, we have a short reflection from Radovan Kopeček, co-founder of the research institute ISC Constance. So he will look a little bit back what we've seen during the conference, and he will also look forward. And what we're planning then afterwards is that we will also have a fire chat. So that will be me asking Radovan a lot of questions that he will ask precisely, shortly, and with as much information as possible. So please stay until the end. We have 4 hours, but I think the last part will be also an exciting one and one of the highlights. I hand now over to my colleague and main author of the first report on cells and modules, who will moderate and lead you through the event. Shravan, please take over.
Thank you, Michael. Hello, everyone. Welcome to this TaiyangNews virtual conference on bifacial technology. So, as Michael already said, our first presenter is Dr. Olga Papathanasiou. I'm very happy to introduce my very dear colleague. Actually, she started a few months ago with us at Taiyang. I also worked with her already over a decade ago during our time at Photon. So next to her job with us, Olga is also a lecturer at the University of Applied Sciences in Hanover. Today, Olga is going to provide an overview on bifacial solar module technology, a summary of our TaiyangNews report we are launching here at this virtual conference. Olga, the floor is yours.
And I unmute. Now he can see me. Thank you so much, Ravan. It's also my pleasure, really, working with you and Michael again, as we are not only colleagues, but all of us also good friends. It's really a great opportunity. Thank you. And okay, I will share my screen now. So can you see the presentation?
Yeah, now, but you have to probably go into the presenters mode.
Can you see that now?
Yes.
The presenters mode?
Yeah, now it is.
Now it is there? Okay. Thank you so much again. So I'm happy to present a brief summary of our latest bifacial PV technology reports from cells to PV systems. But at first, I will take the opportunity to give a brief introduction of our company. We're basically 2 companies and 2 platforms. One is our open solar news platform, TaiyangNews, which in this platform, all information can be accessed for free online, and we give daily updates for solar market and technology news. And we also publish technology reports and market service on production equipment and consumables, and we organize webinars and conferences like this one. And on the other side, we also have a second company, which is our consulting arm, MISCO, and there we provide consultancy services, and of course, at a fee. And this includes communications and strategy development and technical research, which goes even way deeper in detail as we do in our reports and market service. So today we will launch our TaiyangNews report on bifacial solar module technology, and part 1. which can be downloaded for free at our website exactly direct after our conference. And part 2, which is on PV systems, can be downloaded by the end of next week, more probably. So TaiyangNews, as Michael also said, has been covering the developments in bifacial technology since 2017. And the progress is remarkable since we published our last publication. For example, the last publication, we were talking about backability of bifacial modules, which was quite difficult. And now bifacial modules became totally bankable. And the lowest speeds are now on bifacial modules, so far I know, for utility scale projects. And also, we have also the new technical, in 2019, by the end, we had also the technical specification IC 16904.12 for bifacial PV modules, which makes manufacturers' output power rating much easier. And simulation programs have included parameters for bifacial modules, and several research institutes develop bifacial specific simulation programs. I will talk later about that. And the supply chains to support bifacial module production is also well established nowadays. PERC can be made bifacial at no extra costs, at least at cell level. And every advantage architecture beyond PERC is bifacial. The progress with bifacial PV is so large that we decided to extend and split the report into 2 parts. Part 1, cells to modules, and part 2, PV systems. So I will start with part 1, which is covered by my colleague Shravan, as we already told. And so everything in cells, PERC and beyond, are bifacial, except of course of the classical back surface filled cells. Every commercially available cell is bifacial or is possible to be bifacial. High efficiency cell types based on N-type wafers, such as heterojunction, and the relatively new passivated contact cell architecture called TOPCon are also bifacial. IBC technology is also available as bifacial. And ISC Constance in Germany has developed a low-cost IBC process for bifacial cells called Zebra. The bifaciality factor of the various cells architectures ranges between 65 to 75% for PERC and 90% for heterojunction. Here you see also one of very nice graphic from Shravan with many details, which are all explained in our report. I don't have so much time to go into so much details. And I will just take PERC because it's the mainstream bifacial cell. PERC is swinging is really easy. But PERC is not bifacial by default. The effort to turn it into bifacial is really very small. You just need to apply an aluminum grid instead of spreading paste over the full area, and then you can reach bifaciality factors of 65 to 75%. This requires a specific aluminum paste designed for printing fingers rather than the products used for full area prints. But now there are several paste makers that are offering aluminum paste that can support bifacial PERC. Approaches also such as multiple bus bars further facilitate the optimizing aluminum grid. In our report, we have not only for bifacial PERC, but also for TOPCon and heterojunction, really in-depth knowledge and many nice boxes which summarize all of that. When we go now to efficiency levels and bifacialities of selected suppliers, we have many in our report, but here I will just pick the one for N-type TOPCon and P-type PERC. And I have to say that the efficiencies are the best. Efficiencies might be quite different, as we have here 24.9 for Jinko and 40.4 for Jinko in PERC, which is, let's say, it's also not that much difference. And the average efficiencies for N-type TOPCon are not given, only for Jollywood, and Jollywood has turned its complete N-PERT cells line to N-type TOPCon line. And but these are around 24%, and it's really in the same range as for Jinko and Longi with above 23%. And the difference is also that the N-PERT technology needs N-type wafers, as the name indicates, which are 3 to 5% more expensive than the P-type wafers using for PERC technology, which also doesn't work for N-PERT's favor. So when we come to bifacial modules, the main changes required at module level is to make the rear cover transparent. So glass has been the main choice for transparent backside, but also transparent backsheets are available in the market. And so far, two manufacturers, so far I know, Jinko and Jollywood, are offering also modules with transparent backsheets. Anyway, the main reason the bifacial modules are coming also with higher warranties for 30 years instead of output power warranties, 30 years instead of 25. But not only for the glass, also for the glass backsheet configurations. The other change is that for the backside, manufacturers use polyethylene POE foils instead of EVA, and that has something to do with degradation. I come to this point later. And most of the bifacial modules are framed. Modules technologies such as half cell and multi-bus bars are also give also benefits to the bifacial technology. And zero space technologies such as singling and tiling ribbon are also offered in bifacial variants. You can find many details in our part 1 report on this side. And also we have high power bifacial modules based on G12 wafers, which is the largest wafer size on the market today, with 2010 millimeter times 2010 millimeters. But so far only 4 companies are promoting these modules based on G12, such as Canadian Solar, Ryzen, Trina, and Maxion. And also 7 products are promoted by these companies, and they are all based on PERC. Other advances, advanced cell architectures have been not yet scaled up to G12, although Ryzen, I have to say at this point, but this information was very new, announced the launch of heterojunction module based on G12 just 2 days ago. We see here that the power characteristics of these modules are very, very high, up to 655 watts, but also one must think that they are also not so easy to handle the installation. Bifacial modules, we have a variety of wafers for bifacial modules. It's really hard because they are now many, many different sizes, and I just pick up the largest and the smallest, which is at the market today, which is the G1 size, and it is around 158.75 millimeters square wafers. And here we have much more companies as for this for G12. And the output powers are also quite high, and for 72 cells modules, which are mostly used in utility scale parks, we have output powers ranging between 450 for N-type and 420 for mono PERC. And we also see here in the orange bulks the the bifacial gain or the output power on the rear side, but this we should be a bit careful with this because these are measured under STC, standard test conditions, and such conditions you can never find in the field for the rear side of the modules. But still is a way to compare different modules from different manufacturers. When we go now to the field, a very important topic is the degradation of modules. All type of PV modules degrade slightly over their lifetime, and that can be presented in the warranties given by the manufacturers. And in our report part 2, we go more in the degradation which affects the bifacial modules, the difference. And the bifacial PERC modules are more sensitive to light and elevated temperature induced degradation, but the manufacturer seems to have solved these problems by replacing boron p-type dopants with gallium. And the other big problem also for PV scale, for utility scale panels was also in the past the PID, the potentially induced degradation that we had in the past. This now called the PADS because it comes together with a reduction in sign resistance, and this we can also avoid in using special features by inverters. But now with the bifacial modules, we have also PID not only on the front but also on the back side. On the back side, we have PIDP on PERC modules, which is due to polarization effect and is fully reversible, and you can suppress that by using the POA foils. But we also have the PIDC, which is corrosive, and there are many ways to also to handle with that during the cell manufacturing process by cleaning procedures prior to rear side. But all this is also more available in the report. And one point I would like to point one thing, that normally the testing specification ICTS 62841 is really good for PID detection of detection of PID resistivity for monofacial modules, but for bifacial modules, in some cases like in PIDP and PIDC, we need some adapted approaches to get the real results. So PV systems equipped with bifacial modules, the bifacial modules market share is expected to be even higher, to raise, and in 2030 to reach 35%, and almost all of these will be incorporated in utility scale projects, resulting in a 50% share of bifacial modules in utility scale PV market. In this point, I would like to say that the bifacial gain depends not only on the solar modules bifaciality factors, but also on ground albedo and geometry of the PV systems. All good things are three. And this bifacial gain must be also considered for inverter sizing to avoid clipping, but with inverters, we have solis where they will go more in detail of the system, as well as also the sizing of the DC cables, current contactors and fuses to ensure safety of the PV system. Therefore, we need accurate energy yield predictions, which are a bit more difficult, let's say. So I talk about ground albedo. Ground albedo varies not only from surface to surface, but it depends on wavelengths and varies with the spectral and angular distribution of the sunlight, and also depends on vegetation, water contact of the soil, weather conditions, seasons. Here in our report, we also have these tables and some examples. And for example, you can see in the table that even for green grass albedo, you can have various green grass, you can have various albedo values depending also if it is long or short, and if it is green in springtime and summer, and sometimes dry. But with snow is the best example where we can see that the albedo varies dramatically, as fresh snow can have a very high albedos of 0.9, and older dirty snow can have less than the half, 0.4 albedo values. For albedo, since it is also very important for the output power, for the energy yield of the system, PV plants are not only equipped only with pyrometers for direct irradiance, but they also have their ground albedo measurement devices on site, which use 2 pyrometers, one facing up to the sky and one facing down to the ground, to detect the real albedo of the site. So when you want to increase bifaciality, then you also need to put the modules at a higher height. That is more than 1 meter is always beneficial, and the higher the better in this case. And also you need a higher pitch between the rows of the modules, let's say 6 to 8 meters as a rule of thumb, but it is a case by case, it has to be found out in case by case. Therefore, the bifacial modules are a perfect match with horizontal single axe tracking systems, which are higher than fixed installations, and also the row to row distance is also higher for these systems, and they can follow the sun path. So it comes that a HSAT bifacial PV installation reducing LCOE costs of up to 35%. And next to that, the bifacial modules are also very suitable for vertical east-west facing installations as sound barriers or agri-photovoltaic systems. You have no dirt and snow accumulation due to the gravitation force, and the energy peak production curves are shifted from one big peak to a bimodal distribution with peak production in the morning and afternoon hours, depending on the site location, which is also beneficial for the grids. So the energy, when it comes to simulation, the energy yield prediction are more complex as for bifacial panels as for monofacial panels, due to, for example, the variety of the albedo values, but also the backside shading and the mismatch factor of the backside due to this shading of the cells. And the most popular simulation softwares is PVsyst. I mean, PVsyst is almost always used for large utility scale plants, but it is also, next to that is also SEM, developed by Andrel, which is a free of charge software, and SunSolve, which is one of the ray tracing softwares that is the big difference between the several programs. Is if you use a 2D view factor or a 3D ray tracing, and of course ray tracing is more accurate as you follow its ray from the sun, and the shading and mismatch factor can be calculating using these ray tracing simulations, and also such a tool gives the possibility to perform virtual experiments to optimize system configuration. And SunSolve is mentioned here because it's the only tool that works in the cloud and can run simulation in minutes instead of hours or days, like it is the case with other LNT ray tracing programs. And it can be also used to determine parameters for PVsyst. In the next PVsyst version, we can be happy, and will come a model based on 3D shading SEN, as well as an east-west oriented vertical PV modules will be implemented, and the general treatment of tracking systems with the 3D SIN is foreseen to be developed in an ultimate version. So as you see, there is a lot of room for improvement in accuracy of yield simulation for bifacial systems, and both overestimation and underestimation are possible at the moment. So when it comes to the bifacial gain, as we say, the proof of the pudding is in testing, and here we see some real energy yield gains of LONGI's bifacial PERC modules from its baseline, which are ranging bifacial gain between 4% for black fabric and 21% for white coated ground. I would like to end with a conclusion. So bifacial has made enormous progress in all aspects. When we go to the cell level, PERC is currently the mainstream technology, and it's enabling its widespread at any technology, and any technology beyond PERC is already bifacial. In module level, it is easy to make real cover transparent by using glass or transparent backsheets. The supply chain is well established to support bifacial making. And on the manufacturing front, you only need an extra glass loader. When we come to products, bifacial is part of the larger module technology mix, and commercially available products with wide variety of wafer sizes up to G12 are on the market. PV systems, by PV systems, you can optimize the energy yield using modules with high bifaciality factor and sites with high ground albedo, or you can help yourself with maybe white ground cover, and of course, with horizontal single axis tracking systems. We will publish a report, especially on solar trackers, in the next months. But in our report, we still have also some insights. The biggest hurdle for bifacial PV system designers are the accurate yield predictions, and that is because that is quite important, not only for the financing of the project, but also for safety reasons, for proper DC cable sizings and current contactors and fuses. Thank you very much.
Okay, thank you very much, Olga. I think that's a very nice and a very great overview you have given. So it's really informative. I think we don't have a lot of time for questions, but you know, there is, I think I'll pick one or two. So there is a question, SunSol. So what is the accuracy, confidence, and its bankability? Can you comment on that?
I don't have the numbers, and you know, accuracy in simulation software depends also on the person who runs the simulations. That is the point for SunSolve and PVsysts. And but bankability, well, it's really I don't know. We have to talk with the people from SunSolve. I only know what is the difference and what it can offer in types of bifaciality for bifacial modules instead of PVCs. It's more accurate because it enables things that with PVCs are not possible at all. You know what I mean?
Okay. So but then one more question, like, you know, you have worked on so many audits, and so actually, so PID, is it different for a glass and glass backsheet module? So is it going to be any different in terms of PID?
For glass and glass backsheet modules, normally PID does, it's okay. Glass modules might be a bit more prone to PID on the backside with PIDs, but this is solved by inverters when you have this grounding function of the PV system in the inverters. So I think the glass is not the problem. The problem is maybe the encapsulation foils and the cells architecture. So
okay, so thank you very much, Olga, for this wonderful presentation. And probably there are also a couple of questions in the chat box. whenever you feel like you can guide these chat groups, it would be really very helpful.
Sure, I will do so, Shravan. I will go immediately to the chat room.
Thank you.
Okay, thank you. Bye bye.
Bye bye.